law. In this lecture, we'll find out the maximum area of a rectangle that is inside a triangle. In the drawing, we have triangle ABC. Inside this triangle ABC, we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. In addition, we know that side AB of this triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, and this is side BC that equals to 21 units in its length. I repeat again that our mission is to find out the maximum area of this rectangle PQST. So in the first step, we will do a construction. This is to say, from point A, we will do perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will extend the perpendicular from point A and PQ, this perpendicular, until it touches side BC. We define the touching point of the perpendicular from point A and BC, this point as point N, and we define the touching point of the perpendicular from point A inside PQ, this point as point M. So actually, you know that PQST is a rectangle, and you know that the opposite sides of a rectangle are parallel to each other. So side PQ is parallel to side TS in rectangle PQST. And here we have those two angles. They are located between the parallel lines PQ and TS. And we have the rule that corresponding angles between parallel lines are equal to each other. So those two angles are defined as corresponding angles, and are located between the parallel lines PQ and TS, and therefore they are equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles, and they are located between the parallel lines PQ and TS, and therefore they are also equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees because they are equal to each other. They are corresponding angles that are located between the parallel lines, and therefore they are equal to each other. So this angle must be also equal to 90 degrees in its size. So we define the length of side BN as X, and therefore NC equals to BC minus BN. That is to say, NC equals to BC, that is 21, minus BN, that is X. So in total, NC equals to 21 minus X. So I write it down. NC is line segment NC equals to 21 minus X. In the next step, we'll implement the Pythagoras theorem on this right triangle, triangle ABN. So call this right triangle ABN in the new page, and we will implement the Pythagoras theorem on this right triangle, triangle ABN. Side BN equals to x according to our definition. The hypotenuse AC equals to 10 units according to what is given us the question. Here by PT is a relation for Pythagoras theorem. So this is the right triangle ACN that I got from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle ACN, the hypotenuse is AC, therefore the square of the hypotenuse is AC squared, and it must be equal to AN squared plus CN squared. AC is 10, therefore AC squared is 10 squared, that is 100, and it is equals to AN squared. AN is the missing side, so we leave it as it is, plus CN squared. CN is x, therefore CN squared is x squared. So if we found out that according to equation 100 equals to AN squared plus x squared. Here we subtract x squared from this equation, equation 1, and you get that according to this equation, equation 1, AN squared equals to 100 minus x squared. According to equation 1, AN squared equals to 100 minus x squared. In the next step, I'll copy the right triangle A. This is the right triangle A and B. This is the right triangle A and B, because this point is B, so it is the right triangle A and B. So, and this is the right triangle, triangle A and C. So copy this right triangle, triangle A and C in a new page, and we implement on this right triangle A and C the Pythagoras theorem. Again, here by PT is a relation for Pythagoras theorem. Side NC equals to 21 minus x units in its length. The hypotenuse AC equals to 17 units in its length, according to what is given as the question. So actually, this is the right triangle, triangle A and C, this is the correct of the original drawing. This right triangle, triangle A and C, according to the Pythagoras theorem. This will be equation 2. AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. Here AC is 17, therefore AC squared is 17 squared, that is 289. And it is equals to an squared. An is the missing side, so we leave it as it is. Plus nc squared. nc equals to 21 minus x, therefore nc squared is 21 minus x squared. So in conclusion, according to equation 2, we should find out that 289 equals to an squared plus 21 minus x squared. So here we subtract 21 minus x squared for this equation, equation 2. And you get that according to this equation, equation 2, $289 minus 21 minus x squared equals to an squared. Repeat again, according to equation 2, we actually found out that $289 minus 21 minus x squared equals to an squared. So here we'll open the brackets of this expression, 21 minus x squared, and then we get that according to this equation, equation 2, 289 minus, here we have 21 minus x squared equals to 21 squared, that is 441 plus x squared minus 2 times 21 times x is minus 42x, and it is equal to an squared. This is according to equation 2. So here we open the brackets, and we get that according to equation 2, $289 minus 441 minus x squared plus 42x equals to an squared. So here we have 289 minus 441, and here we have x squared plus 2x. So here 289 minus 441 it is equals to, actually here we have 289 minus 441 equals to minus 152 minus x squared plus 42x equals to an squared. This is according to equation 1, but according to equation, this is according to equation 2, but according to equation 1, we have already found out that an squared equals to 100 minus x squared. The next step, we create equation 3 that says that an squared, according to equation 1, must be equal to an squared according to equation 2. So an squared according to equation 1 is equals to 100 minus x squared, while an squared according to equation 2 equals to 289 equals to 152 minus x squared plus 42x. So here we have minus x squared on both sides of this equation. Equation 23. So x squared will get cancelled. After we cancel x squared, we have here minus 152 so here we have according to equation 2 we have here 289 minus 441 plus x squared minus 42x equals to an squared. So here we subtract 152 from this equation and we get that according to equation 3, 100 minus 152 is minus 52. That equals to 42x. So here I have mistake. I repeat again. According to equation 1, we have an squared equals to 100 minus x squared. When according to equation 2, 289 equals to 21 minus x squared. So 289 minus 21 minus x squared equals to this expression 21 minus x squared equals to 21 squared, that is 441 plus x squared minus 2 times 21 times x, that is minus 42x, and it equals to an squared. So here we open the brackets, and here we have minus before the bracket, so therefore it is minus 441 minus x squared plus 42x, and 289 minus 441 equals to minus 152 minus x squared plus 42x, that is equal to an squared. So an squared according to equation 2 equals to minus 152 minus x squared plus 42x, where an squared according to equation 1 equals to 100 minus x squared. And here an squared according to equation 1 must be equal to an squared according to equation 2. This is equation 3. So an squared according to equation 1 equals to 100 minus x squared, and an squared according to equation 2 equals to minus 152 minus x squared plus 42x. So here we add minus 150, so we add 152 to this equation, equation 3, and we get that according to this equation, equation 3, 100 plus 152 is 252, and it is equal to 42x. So actually found out that according to equation 3, 252 equals to 42x. Here we divide this equation 3 by 42, and finally we get that x equals to 252 over 42 is 6. So x equals to 6 units in its length. Here, line segment BN, that is equal to x, according to our definition, is equal to 6 units in its length. And here, line segment NC, that is 21 minus x, so x is 6, so it is 21 minus 6, that is 15. And here we know that side PQ is parallel to side TS, and therefore side PQ also parallel to side VS. So those two angles are defined as alternating angles, and they are located between the parallel sides PQ and CN and C and BS, and therefore they are equal to each other. So if we define this angle as alpha, then the other angle must be also equal to alpha, because they are equal to each other. They are alternating angles that are located between those two parallel lines PQ and BS, and therefore they are equal to each other. Likewise, those two angles are located between the parallel lines NC and PQ, and therefore they are equal to each other. So if we define the size of this angle ACB as beta, then this angle must be also equal to beta, because they are equal to each other. So in the next step, we will prove that the right big triangle ABC, is parallel to this right small triangle, that the big triangle ABC, it is not a right triangle, this big triangle ABC is parallel to this triangle APQ. So why those two triangles are parallel to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this angle, it is a common angle that belongs to both angles, so this angle equals to itself. So we found out that all the triangles, the big triangle ABC, are corresponding equal to all the triangles of this triangle APQ, and therefore those two triangles are similar to each other according to angle similarity rule. So I write it down. We found out that triangle, the big right triangle, it is not a right triangle, the big triangle ABC is similar, this is the sign of similar, to the small triangle APQ. According to angle similarity rule. Okay. Before we continue with the two similar triangles, we just find out the length of line segment AN. According to equation 1, AN square according to equation 1, AN square equals to 100 minus x squared. So AN square equals to 100, x is 6, therefore x squared is 6 squared, that is 36. So in total, AN squared equals to 100 minus 36, that is 64. So AN squared equals to 64. We take out of this equation and finally get that AN equals to the square root of 64, that is 8. So AN equals to 8 units in its length. I'll write it down here. AN equals to 8 units in its length. In the next step, we define the width of this rectangle PQST as B. that is to say side QS equals to B units in itself according to our definition, and we will define the length of this rectangle PQST as A. Because of the fact that PQST is a rectangle, all the four sides inside this rectangle are right angles. So this angle equals to 90 degrees. This angle also equals to 90 degrees. This angle equals to 90 degrees according to our construction, according to what we already found out. Corresponding angles between parallel lines are equal to each other. So inside quadrilateral MQSN, inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral MQSN, this quadrilateral, we have 4 right angles. And according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we write to this quadrilateral MQSN as a rectangle because it has 4 right angles. But you also know that the opposite sides of a rectangle are equal to each other. So an rectangle MQSN, side QS must be equal to side MN, but QS equals to B, therefore MN must be also equal to B. We already found out that AN equals to 8. If AN equals to 8, then side right segment AM, from the drawing it is very easy to see that AM equals to AN minus MN. Again, AM equals to AN minus MN. So AM, this line segment AM equals to AN, that is 8, minus MN, that is B. So in total, actually found out that MN equals to 8 minus B units in its length. This line segment AM equals to 8 minus B units in its length. We just right now found out that the small triangle APQ is similar to the big triangle ABC. And according to angle similarity rule. And from the fact that those triangles are similar to each other, we derive that the following relationship exists between their sides. We know that in any two similar triangles, the ratio between the heights of the two similar triangles equals to the ratio between their sides. So here, the height to side PQ in this triangle APQ is AM. So the height AM in the small triangle APQ over the height AN, that is the height to side BC in the big triangle ABC. AN is the height to side BC of the big triangle ABC. So AM over AN equals to the ratio, that is the ratio between the heights of those two triangles, and it is equal to the ratio between their sides. That is to say, it is equal to side PQ, that is the side of triangle APQ, over side BC, that is the side of the big triangle ABC. So in conclusion, actually found out that because of the fact that the small triangle APQ is similar to the big triangle ABC, the following relationship exists between their sides and their heights. AM over AN equals to PQ over BC. AM is 8 minus B over AN. AN is 8 and it is equals to PQ. PQ is A according to our definition over BC. BC equals to 21 units according to what is given as a question. So in conclusion, I shall found out that eight minus B over 8 equals to A over 21. Here we cross multiply this equation and we get that 21 times 8 minus B equals to 8A. Here we will divide this equation by 8 and you get that A equals to 21 over 8 times 8 minus B. So here we will open the brackets of this expression and finally we get that A equals to, here we have 8 in the numerator and 8 in the denominator, so 8 we can cancel and we left only with 21. And here we have 21 times minus B is minus 21B over 8. So in conclusion, I found out that according to equation 1, A equals to 21 minus 21B over 8. Here we multiply this equation 1 by B, and you get that according to this equation 1, A times B equals to, here we have to multiply this side also of the equation by B, so it is 21B minus 21 over 8 B squared. According to our definition, A is the length of this rectangle PQST, and B is the width of this rectangle PQSB. Therefore, A times B is the area of rectangle PQSB. I repeat again, A times B is the area of rectangle PQST. And according to equation 1, the area equals to 21 times B minus 21 B squared over 8. Okay, our mission is to find out the maximum area of this rectangle PQST. In order to find out the maximum area of this rectangle PQST, we have to derive this equation according to the variable B, and we will equate the derived to 0 in order to find the extreme point of this of the derivative of this equation. So we derive this equation 1, that is to say the derivative of 21b minus 21b squared over 8 according to the variable b. B is the variable that we have to derive it according to the variable b. And we get that the derivative of 21b is 21, minus, we have here 21 over 8, and the derivative of b squared is 2b, of course, and we have to equate the derivative to 0 in order to find the extreme points of this function, of this the area function. Whenever you equate the derivative of a function to 0, you will find out the extreme points of that function. It could be a maximum extreme point or minimum extreme point. Okay, so we did the derivative of this function area of rectangle PQST and found out the derivative of this function according to variable b equals to 21 minus 21 over 8 times 2b, and we have to equate the derivative to 0 in order to find the extreme points of this function area. So we equate this derivative to 0. So here we'll take 21 as a common factor of this expression, and you get that we have here 21, so 21 is taken out as a common factor, so inside the brackets, what is left from 21 after we took 21 as a common factor, what is left is actually 1, and what is left from this expression after we took from it 21 as a common factor, what is left is actually minus 2b over 8 is equals to 0. So here we divide this equation by 21, and you get that here 21 will get cancelled, and we're left only with 1 minus 2b over 8, and 0 over 21 is 0. So in conclusion, we found out that 1 minus 2b over 8 equals to 0. Here we will let 2b over 8 to this equation, and we get that 1 equals to 2b over 8. Here we divide both the numerator and the denominator of this expression by 2, and get that 1 equals to 2b over 2 is b, and 8 over 2 is 4. So here we multiply this equation by 4, and finally get that b equals to 4 units in its name. So b equals to 4 is the width b is equals to 4 units in its name. Now, in order to verify that when b equals to 4, we have maximum extreme point and not minimum extreme point, I actually draw the function this is the function, the area function of rectangle PQST according to in the y-axis we have the area of rectangle PQST, in the x-axis we have the width b. Okay, and here you can definitely see that when b equals to 4, here b is the axis, the width, and when b equals to 4, then the area equals to 42. Therefore, this is maximum extreme point. Again, according to the function, it is very clear that when b equals to 4, when the width of the rectangle equals to 4 units in its length, then we get here the area. The axis y is the axis for the area. The area is its maximum height. Its maximum value. And therefore, indeed, when b equals to 4, we actually got an extreme maximum point. So now we'll find out what is the value of the area of the rectangle will be equals to 4. So the function area of the rectangle is equals to AB equals to 21b minus 21b squared. The area, the function area is 21b minus 21b squared. And when b equals to 4, the area of the rectangle is its maximum value. So we substitute b by 4 in order to find the area, that is the width times the length, that is to say a times b, because a is the length and b is the width. So the area equals to 21b and b is 4, so it is 21 times 4 minus 21. B is 4, therefore b squared, it's actually 21b squared over 8. Here I forgot the 8, so it is 21b squared over 8. So it is 21 times b squared. B is 4, therefore b squared is 4 squared, it is 16. We have to divide it by 8. So the area, the maximum area of rectangle PQST, PQ of rectangle PQST is equals to 21 times 4 is 84. Here we have 16 over 2 is 2, and 2 times 21 is 42. So the maximum area of rectangle PTST equals to 84 minus 42 is 42. So actually found out that the maximum area of rectangle PTSQ is equals to 42 square units. That is the answer to the question. Actually, when the area of rectangle PTSQ equals to 42 square units, then the width B equals to 4 and the length A equals to 10.5. And the area is of course 42 square units. 4 times 10.5 equals to 42 square units. And that is the answer to the question. So in the next step I will summarize the lecture. In this lecture, our mission is to find out the maximum area of this rectangle PQST that is inside this triangle ABC. So in the drawing, we have this is triangle ABC. We know that side AB of this triangle ABC equals to 10 units itself. Side AC equals to 17 units itself. This is side BC. This equals to 21 units itself. Inside this triangle ABC, we have this rectangle PQST And our mission is to find out the maximum area of this rectangle. Okay, so in the first step we did a construction. That is to say, from point A we do perpendicular on PQ. Again, from point A we do perpendicular on PQ, side PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular for point A and side PQ. This point is point M. In the next step, we extended the perpendicular AM by side line until it touches side BC, and we define the touching point of the perpendicular from point A and side BC. This point is point N. So what is the size of those two angles? Actually, use the rule that those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and TS. PQ is parallel to TS because of the fact that in a rectangle the opposite sides are parallel to each other. So in rectangle PQST, PQ is parallel to the opposite side TS, and therefore those two angles that are defined as corresponding angles and are located between those two parallel lines must be equal to each other. But this angle equals to 90 degrees, therefore this angle must be also equal to 90 degrees according to the rule that I mentioned. Likewise, according to the sum rule, here we know that those two lines are parallel to each other, and we have those two angles that are located between those two parallel lines, and therefore they must be equal to each other. But this angle equals to 90 degrees according to our construction, therefore this means angle must be also equal to 90 degrees because they are equal to each other according to the rule that I mentioned, that corresponding angles between parallel lines are equal to each other. Okay, so in the next step we defined the length of this line segment BN as X. We know that BC in total equals to 21 units in itself according to what is given as the equation. Therefore NC must be equal to BC minus BN. Again, NC equals to BC minus BN. So NC equals to BC, that is 21, minus BN, that is X. So in total NC equals to 21 minus X. And in the next step, I copied this right triangle ABN in a new page, and we implemented the Pythagoras theorem on this right triangle ABN. So actually, this is the right triangle ABN that I copied from the original drawing. BN equals to X according to our definition. AB equals to the hypotenuse AB equals to 10 units in itself according to what is given as the question. So in this right triangle ABN, according to the Pythagoras theorem, AB square equals to AN square plus CN square. Okay, AB square, again, AB square equals to AN square plus BN square. AB is 10, therefore AB square is 10 squared, that is 100, and it is equals to AN square plus BN square. AN is the missing side, so leave it as it is. BN is X, therefore BN square is X squared. So in total, actually, according to equation 1, we found out that 100 equals to AN square plus X squared. Here we subtracted X squared from this equation, equation 1, and finally found out that according to this equation, equation 1, AN square equals to 100 minus X squared. This is according to equation 1, AN square equals to 100 minus X squared. In the next step, I copied this right triangle A and C in this new page, and we implemented the Pythagoras theorem on this right triangle A and C. We already found out that A and C, side AC equals to 21 minus X, and the hypotenuse AC equals to 17 in itself according to what is given as the question. Repeat again, the hypotenuse AC equals to 17 and NC equals to 21 minus X. So in this right triangle A and C, according to the Pythagoras theorem, AC squared equals to AN squared plus NC squared. AC is 17, therefore AC squared 17 squared, that is 289, and this equals to AN squared plus NC squared. NC is 21 minus x, therefore NC squared is 21 minus x squared. So here we subtracted 21 minus x squared from this equation, equation 2, and finally found out that according to equation 2, (289 minus 200 minus x squared equals to AN squared). So here we actually opened the brackets of this expression and found out that according to equation 2, we opened the brackets here, so we have here, according to equation 2, 289 minus, here we have 21 minus x squared. 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21 times x, that is minus 42x. And it is equals to a squared according to this equation, equation 2. So here we open the brackets, we have minus before the bracket, so it is 289 and we have minus here, so it will be minus 144. And here we have minus x squared, because here it is plus, so the minus, we have minus here, so it becomes minus, so it is minus x squared. And here we have minus times minus is plus, so it is minus 42x is plus 40x, that is equal to AN squared. So here we have 289 minus 441 is minus 152 minus x squared plus 42x equals to AN squared. So we have two equations for AN squared. Therefore we can get that we have AN squared equals to minus 152 minus x squared plus 42x. This is according to equation 2. According to equation 1, AN squared equals to 100 minus x squared. So we have two expressions for AN squared. Therefore, we added equation 3 that states that AN squared according to equation 1 must be equal to AN squared according to equation 2. So AN squared according to equation 1 is 100 minus x squared, and it must be equal to AN squared according to equation 2. AN squared according to equation 2 equals to minus 100, here minus 100, AN squared according to equation 2 equals to minus 152 minus x squared plus 42x. So here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. After cancelled x squared, in this side of the equation we have minus 100, actually we added here 152 to this equation, and finally found out that 100 plus 152 is 252. So in this side of the equation we have only 252, and the other side of the equation we have only 42x. So in conclusion, according to equation 3, we found out that 252 equals to 42x. So here we divide this equation 3 by 42, and finally found out that x equals to 252 over 42, that is 6. That is 6. So here x equals to 6 units instead. Here we have, this is 97bn, this is equal to x, and x equals to 6. And here, this is 97nc, that is equal to 21 minus x, and x is 6, therefore it is 21 minus 6, that is 15. So, in the next step, we actually know that those two angles, they're defined corresponding angles, and they are located between the parallel lines SB and QP, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So if this angle is alpha, this angle must be also equal to alpha. Likewise, we have here those two angles are also defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is beta, then this angle must be also equal to beta, because they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. In the next step, we actually proved that the big right triangle ABC is similar to this small right triangle. The big triangle ABC, it is not a right triangle. The big triangle ABC is similar to this triangle APQ. So why those two triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this angle is a common angle that belongs to both triangles, so we can write down that this angle equals to itself. It's a common angle that belongs to both triangles. So we shall prove that all the fingers inside the right triangle ABC, the right big triangle ABC, are correspondingly equal to all the fingers in this right triangle APQ, and therefore those two triangles are similar to each other according to angle similarity rule. Okay, again, the big triangle ABC similar to the small triangle APQ according to angle similarity rule. But before that, we have to find out, before we can conclude from the fact that those two right triangles are similar to each other, we can conclude something. We have to find out the value of an according to this equation 1. An squared equals to 100 minus x squared. And we already found out that x equals to 6. Therefore, an squared equals to 100 minus x squared, that is 6 squared, is 36. So in total, actually found out that an squared equals to 100 minus 36, that is 64. So an squared equals to 64. We took out of this equation, and we found out that an equals to the square root of 64, that is 8. So here, an equals to 8 units in length. This is 97 an is equals to 8 units in length. And for the fact that the big triangle ABC is similar to this small triangle APQ, we derive that the following relationship exists between their sides and their heights. That the height AM of the small triangle APQ over the height AN in the big triangle ABC equals to AQ over BC. Again, we derive that AM over AN, that is the ratio between the heights of the two triangles, that is equals to PQ over BC. The ratio between the sides of the two similar triangles. AM is 8 minus B. Yeah, but before that, actually, we defined the width of this rectangle PQST as B and the length PQ as A. Okay, so here we have inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. Again, inside this quadrilateral PQST, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 pieces angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 pieces angle must be equal to 90 degrees in its size. So inside the small quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle MQSN, side QS must be equal to the opposite side MN. But QS equals to B according to our definition, therefore MN must be also equal to B. And here, we just right now found out that AN equals to 8. AN equals to 8. So what is the value of AM? AM equals to AN minus MN. Again, AM equals to AN minus MN. So AM, this line says AM equals to AN, that is 8, minus MN, that is B, according to our definition. And minus MN, that is B. So in total, we actually found out that AM equals to 8 minus B. This line says that AM equals to 8 minus B, AN equals to 8, and PQ equals to A, and BC equals to 21, according to what is given as the question. And from the fact that the small triangle APQ is similar to the big triangle ABC, we derive that the following relationship exists between their heights and their sides. That the height AM in the small triangle over the height AN in the big triangle equals to side PQ of the small triangle over side BC of the big triangle. Or AM over AN equals to PQ over BC. AN, here we have AM is 8 minus B. Here AM is 8 minus B over AN is 8, and it is equals to PQ, that is A according to the definition, over BC, that is 21 according to what is given as the question. So in conclusion, we found out that 8 minus B over 8 equals to A over 21. Here we must multiply this equation, and finally found out that 21 times 8 minus B equals to 8A. Here we divided this equation by 8, and finally found out that A equals to 21 over 8 times 8 minus B. Here we open the brackets of this expression, and here we have 8 in the numerator and 8 in the numerator, so in total 21 over 8 times 8 equals to 21, and we have 21 over 8 minus B, that is 21 and minus 21B over 8. And again, if I found out after we open the brackets that after I opened the bracket, we actually found out that B minus 21. Here we found out that A equals to 21 minus 21 over 8B. So A equals to 21 minus 21 over 8B. Okay, again, we actually found out that A equals to 21 minus 21B over 8. Okay, this is according to equation 1. So here we multiplied this equation 1 by B. So in this side we have A times B, this is equals to 21 times B is 21B. Here we have minus 21 over 8B, that times B is minus 21 over 8B squared. So we found out that according to equation 1, A times B equals to 21 b square over 8. A is the length of rectangle PTSD and PTSQ, and B is the width. Therefore, the length times the width is the area of rectangle PTSQ. We found out that the area of rectangle PTSQ, that is 8 times B, equals to 21B minus 21 over 8B squared. Again, our mission is to find out the maximum area of this rectangle PQST. We found out that the area of the rectangle PTSQ, that is AB, is equals to 21B minus 21B squared over 8. In order to find the maximum area of the rectangle PTSQ, we have to derive the area according to variable B, and we have to equate the derivative of the area to 0 in order to find the extreme points of this area function. So we derive this expression according to the variable B. So it is D, and we have here the function 21b minus 21b squared over 8, and the derivative is according to variable B. So the derivative of 21b is 21, and here we have minus 21 over 8 times b squared, and the derivative of b squared is 2b. So we found out that the derivative of the area of rectangle PTSQ equals to 21 minus 21 over 8 times 2b. So now we actually equated the derivative to 0 in order to find extreme points of the area function. So that is to say, the derivative that is 21 minus 21 over 8 times 2b equals to 0. So here we took 21 as a common factor out of those expressions. So what is left of 21 after we took from it 21 as a common factor? What is left is 1. And what is left from this expression minus 21 times 2 over 8 times b, after we took from it 21 as a common factor, what is left is actually minus 2b over 8, and it is equals to 0. So 21 times 1 minus 2b over 8 equals to 0. Here we divided this equation by 21, and finally found out that 21 over 21 is 1, so on this side of the equation we left only with 1 minus 2b, and here 0 over 21 is 0. So in conclusion, we found out that 1 minus 2b, 1 minus 2b over 8 equals to 0. Here we added 2b over 8 to this equation, and we found out that 1 equals to 2b over 8. Here we divided this expression, both the numerator and the denominator, by 2. 2b over 2 is b, and 8 over 2 is 4. So in conclusion, we found out that 1 equals to b over 4. Here we multiply this equation by 4, and finally found out that b equals to 4 units. That is to say, the length b of this rectangle PQST equals to 4 units. Okay. So now we have to verify that at point B we have maximum extreme. It is maximum extreme point and not minimum extreme point. For that reason, I drew the area function. This is the area function of rectangle PTSQ. In the x-axis, we have the variable b, that is the width of the rectangle. In y-axis, we have the area. And it is very clear from the graph that when b equals to 4, then the value of the area is its maximum value. Here, when b equals to 4, then the area equals to 42 square units. Here B is 4, and the area is at this point that's actually 42. So in this way we actually verified that point B, when B equals to 4, the area is its maximum value. Now we actually calculated the value of the area when B equals to 4. When B equals to 4, the function of the area is 21B minus 21B squared over 8. Here B equals to 4. So here we substitute B by 4. And the area equals to 21 times 4. We substitute B by 4. So the area equals to 21B is 21 times 4 times 21, and B squared is 4 squared, that is 16 over 2. So the area, when B equals to 2, the area of rectangle PTSQ equals to 21 times 4, that is 84. And here we have 16 over 8 is 2, and 2 times 21 is 42. So it is minus 42. So in total, the area of rectangle PTSQ when B equals to 4 is equals to 84 minus 22, 84 minus 42, that is 42. In conclusion, I shall find out that the maximum area of rectangle PTSQ is equals to 42 square units, and then the width of the rectangle, when its area is its maximum value, the width B equals to 4, and the length A equals to 10.5 units. Okay, thank you very much.